Yes. Shall we? Okay, we will start with the three-phase induction motors. So first circuit is to simulate the torque and speed characteristics of the three-phase induction motors. Okay. So we will start with that circuit. So open the MATLAB software, and inside the MATLAB you should open the Simulink library. Okay. So go to the MATLAB. So here we have Simulink library. Click on the Simulink library. So it will open this library. So here you can open the new models. Okay. Yes. So if I open now means it will take long time. So that's why I have already opened it, and I am ready with the tool. Okay. Yes. So the first circuit we are here we are designing is, okay. Sorry, I will make the font size large. Okay, and bold. Okay. So here we are doing simulation of torque, speed, characteristics sorry of three-phase induction motor. Okay. Simulation of torque, speed, characteristics of three-phase induction motors. Okay. So this is the first circuit we are going to simulate. Okay. Yes. So for this interface we require some blocks. Okay. Okay. So what are those means? First we will take the three-phase induction motors. Okay. Three-phase induction motors. Search for three-phase induction motors. Sorry. Just search for induction, it will show the motors. Yes. So here there are multiple motors. So here yes. Okay, search for asynchronous machine, SI units. This one, asynchronous machine, SI units. So this is a three-phase induction motor. So add it to the model, right click and click on add model. Okay, add block. Sorry. Okay, the software has some issues, so it is automatically closed. Okay. So after taking this asynchronous machine, okay, you need to give the parameters. Okay. Just double click on this. So rotor type should be squirrel cage, and motors parameters, that is 5.4 HP, 400 volts, 50 Hz, 140 RPM. Then mechanical input should be speed. Reference frame must be stationary. Okay, so these are all the changes you need to do inside the motor. Okay, then click on apply. Okay. simulation of speed, torque, spot characteristics of three-phase induction motor. Okay, done. So we have given the parameters for this motor also. Okay, so after this go to the library. Okay, so here we need to take one more multiple blocks. Okay, search for power GUI. Okay, so this one, take the power GUI block, place it here. Okay, so then we need AC voltage source. Search for AC voltage source, you will get this one. Okay, so symbol should be outside the block. Okay, plus symbol. Okay, so you need to give these to A, B, C, three of them. Okay, so here give the AC voltage source. So peak amplitude must be 220 into square root of 2. Okay, then the frequency must be 50. Okay, then click on OK. Done. So this is about the input power supply. Okay, so you can copy this three times. So here we need to connect it for the 3 terminals. Okay, for that you need to copy it 3 times. Just right click and drag it. Okay, so here just you can name this as A. Okay, this one as B terminal, this one as C. Okay, ABC, since here there is a ABC combination, so you can name it like this. Okay, so here phase angle should be different. Okay, so here B phase, this one phase angle should be minus 120. Then click on OK. So third one, that is C. C's phase degree must be minus 240. Okay, then click on OK. Yes, so then we required one more block, that is ground. Okay, so take it correctly. Ground, there will be multiple blocks. Okay, you should take correct one. Search for ground, you will get multiple ground pins. So scroll down. So here it will be like ground. Okay, lines with the name of ground. Okay, right click, add this to the simulation here. Okay, then connect these 3 supplies to the ground pin. Okay, like this. So connect it like this. So after that B phase, connect it like this. Ground will be connected like this. Okay, yes. So after that we will connect C to C, B to B, and A phase to A phase. Done? Yes. Okay, yes. So so after this we need to take one more block. So that is bus selector. So here motor values, we need to read the motor values. For that you need to take bus selector. Take the bus selector and you can connect it to the M terminal. Okay, so yes, connect it to M. And then we need a scope. We will get in the sinks. Go to the scope and take the scope block. Okay, so here you can take any multiple graphs. Okay, since we are plotting for speed versus torque, so just we will take the 2 axes in the graph. Okay, open double click on the scope, go to the settings. Okay, after go to settings, change this number of axes. make it as 2. Okay, then click on OK. So it will have 2 inputs. The scope block will have 2 inputs. Okay, then we need to take 2 values from this motor. Okay, those are like here, since we are taken speed versus torque, so here also double click on the bus selector. Yes, so here go to this rotor measurement, sorry, mechanical, yes, here mechanical, go to this mechanical part. So here already default there will be signal 1 and 2. Okay, so remove this signal 1, remove this signal 2. Okay, so now you need to select torque, click on select. Then we need speed, click on speed here and click on select. We have selected torque and the rotor speed. Okay, so these 2 values we can give it to the scope output side. Then click on apply. Okay, OK. So then you can connect the bus selector to the scope block. Okay, so directly you can connect this first signal to here, second signal to here. That's all. So after that you have to take ramp, go to the signals, sorry, it will be under the sources. Okay, go to the sources. So here there is a ramp signal, add this block, connect it to the W. This is the load. Okay, so after connecting, double click on the ramp block. Okay, so here the slope. Okay, the slope value must be slope value must be 50 into pi, sorry, pi should be small letter, divided by 10. Okay, now so then that's all. You can click on OK. So now we have given the input power supply, load, and also we have connected the output here. Okay, so yes, this completes the circuit. So now you can save this file and you can run it. Okay, yes, we will try this one. So just we will save this file, click on save. So here in the desktop we have already created the project folder. Okay, go to the desktop, here MATLAB Simulink files. So here save the file as speed versus torque. Okay, 3-phase induction motor. You need to use the underscore. Okay, don't use a space, you use underscore. Okay, speed versus torque, 3-phase induction motor. Click on enter. Okay, so now you can run the simulation and you can check the output here. Okay, so so now click on this run option. Wait for some time. Okay, so now it is completed. Just double click on the scope block. Yes, so here you can find the output. Okay, so there is a speed and also torque. This is a torque, this is a speed. Now the speed is gradually increasing. Okay, so because we have given the ramp signal here. Okay, so ramp is nothing but it will increase slightly based on the time intervals. Okay, so there is a linear speed increases. So when the speed increases, like initially the torque will be more. Okay, torque will be more slightly. When the speed increases, the torque also increases. Then at the certain point the torque will be reduced because there is a higher speed. When there is high speed, when there is a speed is maximum, then there will be a low torque. Okay, and you can call it as you can tell it as decreasing of the torque after certain speed. Okay, so in vehicles also, so at the initial when the vehicle is moving from the static point. Okay, so I will give you an example. So think a vehicle is standby. Okay, so vehicle is turned off and it is in stop position. So we will start that vehicle and we will press the accelerator button. Okay, accelerator pedal. Okay, so when you press that, there will be a more torque. Okay, car should move from static state to moving state. Okay, so for that it needs more torque. So that's why initially there will be more torque, and when the speed increases to maximum, there will be low torque. Okay, so in vehicles and all, you can observe. So when you put a bike in a fourth gear, okay, or fifth gear, and if you moving in a low speed, that is 20 kilometers per hour, so bike will it will not move smoothly. Okay, it will turn off suddenly. Okay, and it will make some other sounds like that. Okay, so because there is a very low torque when the speed for the higher speed. Okay, for the slow speed there will be high torque. Okay, when we require torque means we will switch the vehicle to second gear, third gear. Okay, like that. When we required high speed means we'll switch the gear to 5, 6, like that. Okay, now so like that you can see here, you can observe the waveform here. Okay, so in the initial there will be high torque, so you can observe here by zooming like this, and the speed is around 5 to 10. Okay, and here the torque is 150, like that. Okay, and also here in this point torque is reducing and the speed is 80 to 130, like that, near to 130. Okay, so still you can see here. Yes, so here from this point the speed torque is decreasing. Okay, after 6.5. Okay, so this is the time, this is the speed, this is the torque. Okay, with respect to time. Yes, so you can add one more block called sample and hold. Okay, to get more accurate output results. Okay, so for that one block, so you can easily add it by searching sample, search for sample and hold, sample and hold. Okay, so here M is missing, or else you can find it in the here signal routings. Okay, okay, so here just add this block sample and hold. Okay, so we'll connect here this one and connect the torque. So I will remove this connection, connect the torque to this in IN terminal here. Okay, so after that we required one more block, that is step. You can get it in sources, go to the source, here you will get the step. Okay, so we'll get the step wave here. Double click on the step. So here the step time, it must be 1.2. Okay, and final value 1. That's all. You can click on OK. So connect it to the yes. yes terminal here. Okay, and then double click on this sample and hold. Okay, so both are 0 0, so we need to like you can change these parameters if you required means, then no need to change. Okay, so here we will change this value to 62.5, so which is came from the last outputs. Okay, then click on OK. So here 62.5, click on OK, connect this to scope. Okay, so here there will be multiple blocks inside this is called subsystem. Okay, so then we'll run this simulation. Yes, so now open the scope block. Yes, so here you can see like initially it was showing like more disturbance, but here it is showing linear. Okay, so this is a like sampling and holding, so it will average these values. So initially it will average these values. When you use the sampling and holding block means it will avoid this noise and all. It will give the exact average values of the multiple values. Okay, so then you can obtain this this scope, which is speed versus torque. So there is one more like block called XY graph. You can use this also. Okay, just add this block to the graph here. Okay, connect this first one to let us say this one, torque. Okay, first one will connect it to the torque, and second one we will connect it to the speed. Okay, so after this let us run this simulation and check the output. Okay, so it is completed. Okay. So this one is torque, this one is speed. So wait for some time, so like it's lagging. So select this line and name it as speed. minus 10, 10, sorry, so x minimum, x maximum, y will give minus 100, so here 100. Okay, so let us click on OK. Okay, we got the graph in this scope. Okay, so it is not available in this type of blocks, so let it be. Okay, you will get this okay, so you will get the output graph here. Okay, you can check the torque versus speed characteristics based on the with respect to time. Okay, so this is this is a topic based on three-phase induction motors. So here what you will do, you will check the speed and torque characteristics when you apply the load in the linear way. Okay, done. So this is about this speed versus torque characteristics of a three-phase induction motor. Okay, so if you have any doubts related to this module, you can ask. Okay, so all of you done this block. Done. Okay, so we'll move to the next one. Okay, so the next one is like we will check the different load conditions for the three-phase induction motors. Okay, three-phase induction motor at different load conditions. So this we have already done in the DC motor. Okay, so now we are trying it in the three-phase induction motors. Done. So similar here we required a module called asynchronous machine SI units. Search for asynchronous, you will find the motor here. Take this block. Okay, so after this block we need AC voltage source. Take AC voltage source. Okay, so after this we need power GUI block. Search for power GUI block. Okay, take the power GUI block here, place it here. AC voltage source, will place it here. Then we need a bus selector. Take a bus selector. Okay, add it to the model. Then we required ground connection. Take the ground block. So here, next we need a step block. Let's take the step block. Here, add the block to the model. So keep this model here. So we have taken this one. Yes, so now we required one more, that is bus selector. So we should take bus creator also. Take the bus, so we'll get it in the signal routings. Okay, bus creator and bus selector. Sorry, we have taken this bus creator. Okay, select this one, delete this one. Okay na. So after this we need a scope block. So scope we will get it in the sinks. Add this block. Also we require display. Add the display module. Okay, and then we require sum block. We will get in the math operations and take the sum block here. Add this block. Okay, and after we need a gain block. So gain block is available in the math operations. Take the gain block. Okay, so that's all we require for this module. Okay, so all these we will connect it now. Okay, so initially we will name it as A. Name this input AC voltage source. Okay, A, and then we required one more B and C. We will name it as B, this one as C. Done. Okay, so connect the ground here at the for the three input voltages. Okay, and this one will connect it like this. So after this connect C port, B and A. Okay, done. So after this connect this bus selector to the M block here. Okay, asynchronous machine is okay. So yes, so here we need to change this settings here. Go to the asynchronous motors. Okay, here you need to change this to squirrel gauge. Mechanical input speed, here stationary. Okay, here you need to select 15th one. Okay, this one. These are the basic settings for the asynchronous machine SI units. Okay na. Squirrel gauge, and here 15th one 5.4 HP, 400 volts, 50 Hz, 1430 RPMs. Okay, then set it to the mechanical input must be speed, reference frame must be stationary. Click on OK. Done. Yes. Okay, input. So input must be torque. Sorry, input must be torque, mechanical inputs. Click on OK. Done. So then double click in this bus selector. So here remove the signal 1, signal 2, remove. Then go to the mechanical part. So here we'll take speed, torque. So after this go to the stator measurement and take stator current. This one, first one, stator current is A. Select this one. Stator current is A. Okay. Yes. So after this, so we need to take 3B and C. Stator current A, stator current B, stator current C. Okay, then rotor current A, rotor current B. Here click on the rotor measurement. So here it will be available. Rotor current A, B and C. Okay, so these are all the values you need to take. There are 6 total, 6. So after that click on OK. Okay, done. So here you can zoom here and you can enlarge this one. So here we are getting total 6 outputs from the bus selector. Okay, like this. You can increase the size. Okay. Now you can connect to the scope or anything. So take the scope block, double click on this scope block, go to the settings. So here the number of axes must be 2. Number of axes must be 2. Then go to the history. Select the save data out to workspace, and deselect this one. Go to the generals. Here this one bottom axis only, change it to all. Okay, then click on OK. Close this. So here there is a scope. So here we will display speed and torque. Okay, speed versus torque. Then take this bus creator, double click here, double click on the bus selector. So here you need to take it for 3 number of inputs. Okay, so 3 for rotor current, 3 for stator current. Okay, so enlarge this one, copy this again for the stator. This is for stator, this is for rotor. Okay, so after this connect this first one, that is speed. This one is torque. Okay, and next one, this is stator current A, stator current B, and stator current C. Then we have rotor current A, rotor current B, and rotor current C. Okay, then we need one more scope. Go to the sinks, take scope block, double click here, go to settings, same. Okay, so 2, go to the history, select save data, deselect limit data points, go to the general, bottom axis only. So here make it as all, then click on OK. Okay, done. Close this one, connect it to the connect one to the stator current, one to the rotor current. Okay, so here and one to here. Done. So yes, so this is stator and rotor current, stator and rotor current. Done. So now we need to connect this gain block to the speed. Okay, so gain value must be, double click on the gain. Okay, gain value must be 60 divided by bracket open 2 divided by 2 into pi bracket close, 60 divided by 2 into pi. Click on OK. So this one you need to connect between this one speed and scope. Okay, connect here. The scope block should be here. Okay, and next take the display module and connect it to the speed here. Okay, so it will show the speed. And again, if you required one more means, take display and connect it to the torque. Okay, so then take this sum block and step block. So this one we will use it for load, input load. Okay, now double click on this. Yes, so we have set it, we have already set this motor. Okay, so like let us check it. Yes, we have selected this 15th one. Okay, yes, so here this is small changes. So this one reference frame must be rotor. Okay, then click on OK. Then we'll set this voltage. So A voltage source, click here. Okay, now so here 100 and frequency, sorry, 1 minute. Yes, so here we need to change it for 326.54 and frequency must be 50. Okay, click on OK. And second one, here we need to give 326.54. So after this I will show the values. Okay, this is for second, that is B, input voltage B. And here here you need to give the phase degree. Okay, phase degree should be -120. Then click on OK. Go to C. So here the frequency will be 50. Okay, and the phase 120 degrees, and the peak amplitude must be 326.54. Okay, this is the default. This is a voltage, this is a phase degree, and this is a frequency. For P, voltage, phase angle -120, frequency must be 50. For A, 326.54 voltage. Okay, phase here we will make it as 0 and frequency will be 50. Okay, then click on OK. Okay, now so after this we will connect this sum block. Okay, double click on this step. So here we will give three different loads. Okay, so for that you need to copy this, for one for no load. Okay, so that I will show later. Okay, so copy this 4 times, one for no load, then like quarter load, then half load, then full load. Okay, so this one will name it as, yes, so this is t is equal to 3 seconds, this one t is equal to 5 seconds, this one t is equal to 10 seconds, this one t is equal to 13 seconds. Okay, so after that double click on this first step wave. So here you need to give the step time as 3. Okay, and then final value here we will give it as 26.72. So after this click on OK. Then for the second load, double click here, step time must be 5, final value it must be 13.36. then click on OK. For the third step wave, step time must be 10, final value 6.68. Then click on OK. Then the last one, so step time must be 13, final value must be 6.68. click on OK. Okay, so after this, double click on this sum block. So here we need to change this plus to change it 1 plus and 3 negatives, 1 plus and 3 negatives. Enter. We got this much, so you can increase this one. Okay na. So first one we'll give it to here, second one connect this to this step 5, third one connect here, fourth one connect here. Done. Then the output of this must be connected to the TM means torque. So here you can check this input torque, like input loads. Okay. Take the scope block here, you can connect it here. Okay, so I will show values one more time. This one, first step wave, step time must be 3, final value must be 26.72. okay, then second one, this step time must be 5, final value must be 13.36. step wave 10, final value 6.68. then again fourth one, step time must be 13, final value must be 6.68. then click on OK. Okay, then go to this settings here. Okay, so it says stepping options, click here. Okay, and select this one, enable stepping back, select this one. So here you need to give 10 and here you need to give 5. then click on OK here. Here the simulation stop time must be 15. Okay, this one, stepping options, go to here, enable this one, enable stepping back. Maximum number of saved back is 10, interval between stored backs is 5. Then click on OK and run the simulation. I'm having some error. There is some error in the scope, I think. Okay, so I will delete these scopes. Again I will take. Okay, so double click here. So it is, if your model is running means it's okay. Okay, if you have any error means you can make changes like this. So now I got the output here. The model is running. Okay, so let us check the input loads, so whether it is correct or not. Double click here, auto scale, yes. So initially from 0 to 3 it is no load, and 3 to 5 is full load, 5 to 10 is half load, and 10 to 13 is quarter, 1/4 load, and after that no load. Okay, this is the input loads. Okay, then I will check the output side. Double click here, it will show speed versus torque characteristics. So yes, so here you can see okay, let us name this one. So first one is speed. Here we'll name this line as speed. Second one is torque, name it as torque. Double click here, yes. So this is electromagnetic torque, this is the speed. Yes, we'll just zoom here. Okay. So here you can see initially, like we will compare this input and output signals. Yes, so here there is an input scope. This one is output. Okay, see here correctly. So 0 to 3 is no load. Okay, so here also check here, the speed is maximum here. Okay, speed is maximum 0 to 3, and torque is less because there is no load. Okay, if there is no if there is load means torque will increase, if there is no load means torque will be low. So speed is high here, the exact 1500. Okay, and from from 3 seconds to 5 seconds there is full load. Full load means speed will reduce. Again here the speed is reduced. Okay, and here torque will be maximum because here we have applied full load. Okay, that's why torque will be more and speed will be minimum. Okay, lowest. Then again we will decrease the load here, full load to half load. We will decrease the load, and again here load decrease means speed will increase 5 seconds to 10 seconds. 5 to 10 seconds, there will be half load. Half load means speed will be medium and the torque will be medium, okay, compared to the initial stage. Okay, torque will be reduced when the load is reduced. Again, from 10 seconds to 13 seconds, load is reduced to 1/4. So again, load is reduced means speed will increase slightly. Okay, speed will be increased and again torque will be reduced. Okay, after 13 seconds, there is no load here. Okay, no load means the speed will be at the maximum and the torque will be at the lowest. Lowest is nothing but 0. Okay, so this is the the 3-phase induction motors at the different load conditions. Okay, this is no load, this is full load, half load, quarter, 1/4 load, and again load, no load. Okay, so you can check it for different conditions. So both are same, DC motor and 3-phase motors, there will be not much variations. Okay, so the variation is nothing but the input power supply. So there we will use DC power supply, so here we are using 3-phase supply, that's all. Okay, so after this you can also check the stator current and rotor current here. So it will also show the output, stator current and rotor current. Okay, so I will explain all 3 graphs now. So this is the stator and the rotor. You can zoom it using this scope. Okay, so here you can see so this is the no load. Okay, in the sense of no load, there is no much current. Okay, here also there is a minimum current, but in this okay, once again I will name this one. So this one is stator, first one is stator current, and second one is rotor current. Okay, yes, this one is rotor current, this one is stator current. Okay, so then from 3 to 5 there is a full load. Full load means there will be high current. This is a 3-phase current, so current will be more. Okay, you can check it on both the windings. Then from 5 to 10 there will be half load. Half load, the current will be reduced. Then 10 to 13 there is 1/4 load, and from 13 to 15 there is no load. Okay, it will be 0. Like this you can obtain the current and speed characteristics for the different load conditions for a 3-phase induction motors. Okay, so this is for 3-phase induction motor. Okay, so if anyone have doubts related to this simulation, you can ask. So like parameters, I will show it once again. So here this is for no load. Okay, and for the no load you need to step time 3 and final value 26.72. Then there is this is full load. So full load, for we will use 13.36. Then for half load we will use 6.68. Then for the 1/4 load we will use 6.68, 13. Okay, so here no load will be positive, and remaining full load, half load and quarter load will be in the negatives. Okay, this is all about the 3-phase induction motors. Okay, so if you get any errors related to scope block, means just remove the old scope blocks and add new one, that's all. Okay, so if you done that one, means it will work. Okay, no? Okay, so then you can save this file. So I am recording this class, I will upload it to the YouTube channel, so there you can watch it. Okay, if you have any doubts, or if you have done if you have incomplete model, means you can continue with that video series. Okay, yes, different load conditions conditions for three-phase induction motor. Okay, different load conditions, three-phase induction motors. Okay. Yes, so this is all about these two circuits. So I will just show you 2 to 3 circuits in the class. Okay, after this class you can